right, hi everyone. Thanks for joining today for today's webinar from PVsyst to PlantPredict, seamless model, import, and AI-powered comparison of results. Let's get going. So from an agenda perspective, I'm going to start with an introduction of the presenters and provide a brief overview of PVsyst and PlantPredict. I'll provide some context as to why we built a PVsyst import feature into PlantPredict. I'll then give a demo showing how we can import a PVsyst project into PlantPredict. I'll hand it off to my colleague Arthur to provide a bit of a comparison between the variant and prediction created by my demo. Arthur is then going to provide more detail into how the import tool works, what it pulls in, what it doesn't. We'll provide some closing thoughts on upcoming features and webinars, and then we'll try to leave about 10 minutes or so for Q&A. So I'm Jason Spokes. I'm the Senior Product Director for PlantPredict. Like I said, I'll be leading the first half of the webinar, the demo portion, joined by Arthur Ano, our Principal Performance Engineer with PlantPredict. And like I said, he'll be taking more of the second half. Okay. Turn my camera off. And so about Terabase Energy. So we're a Berkeley, California-based company founded in 2019. We've raised over 200 million through a Series C round, including a recent investment from SoftBank. We're building digital and physical solutions that help accelerate the deployment of solar, and that's what's illustrated here. On the left, we provide several engineering software products for the development and pre-construction phases of the project. Central to this is PlantPredict, our solar energy performance modeling application, and this will be the focus of today's webinar. PlantPredict's API, as illustrated, extends its usefulness into commissioning and operations phases where real-time models may be run in parallel with operating assets. We also have several construction products and services, including a construction management platform that uses the largest autonomous commercial drone fleet in the US, capturing 3 gigawatts of projects every day, and has been deployed on more than 30 gigawatts of projects to date. For the physical construction world, we have our installation automation solution, TerraFab, which delivers a mobile factory to your project site, complete with an assembly line and rovers to automate the module to torque tube to pile assembly. To date, we've completed more than 100 megawatts of automated installation and recently released version 2 of the solution. Finally, we have our plant controls team that provides a full set of SCADA and power plant control services, including hybrid control systems. Diving deeper into our PlantPredict suite, we have several cloud-based software applications and partner products that can be bundled. Our core product is PlantPredict, which has been trusted by the large-scale solar industry for over a decade. Design Pro, Terrain Pro, and Voltage Pro provide targeted solutions for specific engineering challenges common to the solar industry. The PlantPredict API, as mentioned before, facilitates automation and integrates PlantPredict with other Terabase and third-party applications. We're also a reseller of 2 applications, which are also integrated into PlantPredict. So PV Radar, soiling analysis software. It's good for techno-economic sort of soiling and cleaning analysis. And Power UQ brings a Monte Carlo-based uncertainty analysis functionality into our suite. We also have several industry partners that offer direct integrations within PlantPredict, such as Array Technologies and SunSolve. And all of our product tiers and pricing information are published and completely transparent and can be found by going to plantpredict.com/pricing. Okay. So let's get into the real meat of the webinar. So why did we build a PVsyst to PlantPredict integration or import process? Well, first we we believe that modern solar engineers use multiple performance modeling applications. And that's done for a variety of reasons. So each application has its pros and cons. There's really not one performance model out there that is best in all categories, sort of technical capabilities, architecture, and ease of use. Additionally, multiple companies interact on the same project. And so different companies have different tech stacks. And if you're interacting with different companies for the same project, you may be interacting with different models. Some models are better suited for different project phases, and projects have long lifespans. So what made sense 2 years ago may no longer make sense today. Second, compatibility is a core PlantPredict strategy. So we believe that more on-ramps and off-ramps into and out of PlantPredict means increased productivity for our customers. And as an example, we currently have 24 different software applications that are directly integrated into PlantPredict. That means when you log into PlantPredict, you have access to data and capabilities from 24 different software applications. It's not just the data that you bring to the table. Similarly, we accept 22 different file formats for import and export. And third, customer demand. So we've been approached by numerous customers who have asked for this, and we know that manual translation is laborious and error prone. There's a lot of data in these models, and getting them between different tools can be a challenge. So with that, I'm going to bring up our first poll question. And I think hopefully that is live. Rafal, is the poll question live?
Yep, go ahead.
Okay, good. Well, so in the spirit of integration, where should PlantPredict focus future integration efforts? So other performance modeling software applications, or with design and engineering software applications, or with data providers, or on the operations side with asset performance management and other types of operational software or other. And I encourage, if anybody has any specific applications that they're interested in collaborating or integrating into PlantPredict, to please leave that in the webinar notes at the end of the session. Okay, so I am seeing about half of respondents are coming in saying design and engineering software applications are preferred. And then actually, interestingly, about a quarter saying on the operational side. Other performance modeling applications and data providers less so, and 0 on other, maybe because other is a little vague. Okay. Great. Okay, so thanks for that. And let me go back to my presentation here. All right. So with that, I'm going to start the demo portion of the presentation. Let me step out of the slide deck. And okay, at this point, you should all be able to see my screen with PVsyst. So I'm going to start in PVsyst. And so right now I'm within a project within PVsyst. This is webinar 20. It is at a site called Crescent Heights, which is in Texas, and I've got a media norm weather file, and I've got 3 different variants. So my VC0 variant is a Trina 570 watt module with 31.1 megawatt peak, 22 megawatt AC, and it is a 2D variant, so there's no 3D scene. I had selected the unlimited tracker option for trackers themselves. The second variant, VC1, is exactly the same as the first, except that I've added the 3D scene. And the third variant introduces a 2 different modules, so a blend of modules, but otherwise is the same as the previous 2. Let's just take a quick look into the first variant to see on the system side how it's set up. So you can see we've got our 570 watt module. The bifacial system is turned on. So it is modeling the bifaciality of the module. We have a Sunny Central 4.4 MVA inverter, and then we've got 5 subarrays. So and 3 different DC-AC ratios across those 5 subarrays, 30 modules per string, and hopefully that gives you a brief orientation of what we've got here. I'm not going to go into detail within all the losses and other settings that can be configured, but just wanted to get a sense of what's in there. Now, I've already run these 3 variants, so I already have the results accessible. What I want to demonstrate now is how we go from PVsyst to PlantPredict. So the first thing we're going to do is we're going to go export this project from PVsyst. So when I do that, what PVsyst is going to do is it's going to zip up the required files to describe the project and variants. So I'm going to go ahead and save this. And let's take a quick look at what's included in that zip file. So when I open up this zip file, I can see that I have my MET file, which is my weather data. I have a O&D file, which is my inverter. I have the 570 watt pan file. Now notice I don't have the 580 watt pan file. And the reason is because PVsyst only exports pan and O&D files that are not included in the standard PVsyst library that's shipped with the software. So custom or module files and inverter files that you bring into PVsyst will be exported, but if it's included in that sort of default library, it's not going to be exported. Now, there are tricks within PVsyst to get PVsyst to export it. But that's sort of beyond this webinar. But I wanted to flag that because we're going to see the implications of that when we get into the import within PlantPredict. I also have my project file and my 3 variant files of VC01 and 2 and VC01 and 2. Within the variant, that's where PVsyst defines the architecture, the losses, all of the settings for the simulation, as well as the 3D scene. Okay. So now let's hop into, let's go to PlantPredict, and let me open up my browser. Okay. And so within PlantPredict, I'm within my projects, and I'm going to go to import project. And we now have an import PVsyst zip, which I'll click on, and I'll select the Webinar 20 project. And so what PlantPredict has done is it's read that zip file, and it hasn't fully imported the project yet, but it's giving me information about what it's read. And so we can take some actions here before we actually import the project and create the project and the predictions within PlantPredict. So first of all, I can see that the project name will be created as Crescent Heights, which is the site name. I'll change this to Webinar 20. And it's telling me I have 2 predictions to create, interestingly, not 3. And it's saying that there's one more variant which becomes importable once the Trina 580 is resolved. So as sort of mentioned previously, that's creating a little bit of a problem when we try to import because that pan file isn't present. Scrolling down some more, we can see the 3 different variants, and we can see what's sort of contained and what's ready to import and what's maybe some warning flags. So in the 3rd variant, which included the 580 watt module, we have a warning and we have a sort of needs attention. So let's expand that. and better understand what's going on. We can see that the weather data was imported fine, the inverter was imported fine. The module file, first the 570 watt module file was imported fine, but the second module file was missing. So we have an option. We can either select an alternative or select a match from within our PlantPredict library, or we can upload a pan file. I already know that this 580 watt module is present within my PlantPredict library, so I'm going to go ahead and select that, which resolves that issue, and now this variant becomes importable. There's also another, there's a warning, a bifacial discrepancy warning. And this is, there's a couple of situations that can happen when you import, and we try to do our best to sort of warn people of some nuances between PVsyst and PlantPredict where things don't line up apples to apples. And the bifacial discrepancy is one. So in this particular case, for this particular variant, I had turned off the bifacial, I basically disabled bifacial within that variant, within the third variant. And in the first two variants, it was enabled, and so there's no warnings there. But in the third variant, it was disabled. And this is just a nuance between PVsyst and PlantPredict. In PlantPredict, if it's a bifacial module, we're going to model it as a bifacial module. In PVsyst, you have the option to sort of turn off that bifaciality. And so we're giving you a warning that, yes, you can import this, but just be aware that it's going to be modeled as a bifacial model. And that therefore there's going to be it's not an apples to apples variant to prediction. Okay, so let's say that I'm happy with this. I'm going to go ahead and create the project. And at this point, it's translating all of that and sort of bringing that into PlantPredict. So it's created a webinar 20 project, and I can see that I have 3 predictions which line up with those 3 variants. Let's step into the 2D version. Before I go any further, I just want to give a really super brief kind of highlight that we just this week released the ability to import projects from PV Farm. So you can now not only bring in the 3D shade data, but also the 3D scene data, but also all of the sort of blocks and arrays and that hierarchy from PV Farm. So I just wanted to give it, because it's a brand new release, I just wanted to give a quick shout out on that. But now that we're in the 2D prediction, let's quickly open up the block builder, and we can see that those 5 subarrays have been translated here into PlantPredict's version of those 5 subarrays. Let's step back out. I'll go ahead and run the prediction. Now, I haven't changed any settings. This is pure, just straight import from PVsyst. And we're going to quickly just see how do the results line up. And if I go back to PVsyst, we were at 53.76 gigawatt hours. And if I look at the results in PlantPredict, we're at 54.01 gigawatt hours. So that is I think about a 0.25 gigawatt hour delta. And so that's a little bit less than 0.5% delta, just without any modifications to the PlantPredict model. Okay, let's step out and let's take a look at the 3D version. And let's start, let's go into the 3D scene. And while I'm going to go ahead and queue up the calculations, just so they're running in the background. And let's take a quick look at what we have in the 3D scene. So this is our 3D scene. We've got some sort of tree lines simulated as simple rectangles. And if we were to go over to PVsyst and take a look at what was in the PVsyst scene, You can see that we basically have, or we have the exact same scene. Now, one thing I want to point out here, I'll select one particular rack. From an electrical effective shading perspective, I had set this up with partitions. And so I had one rectangle in the Y direction, two rectangles in the X direction, which basically means that I had an East partition and a West partition along my tracker row. When we bring that into PlantPredict, we basically have this same, the sort of equivalent setting was chosen, which is the step fractional electrical shading, and the number of horizontal step fractions for bays too. So that essentially creates two, sort of an east and a west, a two sort of, it's not exactly a one-to-one match of the way that PVsyst does partitions, but it's sort of our PlantPredict equivalent. Okay. And let's see. So interestingly, let me refresh shading calculations. Already, okay, that's what I thought. Let's take a quick look at the results. So this is the results of the 3D shading calculations. I'll turn on a relative scale. Obviously, there's more beam shading, so we're looking at beam shading loss now. More beam shading on the near the tree line. Shading electrical effect is a little more distributed, and the transposition, we can see that there's some gain in the south-facing racks and some losses in the north-facing racks. All right, let's step out, and I will go ahead and run the prediction. Now, again, I haven't changed any parameters once I've brought it in from PVsyst. Let's take a look at what PVsyst was at. PVsyst was at 51.186 gigawatt hours, and PlantPredict is at 50.92, which is about a 0.26 gigawatt hour delta. And again, that's about a 0.5% delta. Okay, and with that, I'm going to stop sharing and hand it over to my colleague, Arthur, who's going to take us a little bit deeper into the import process and some comparisons between PlantPredict and PVsyst. So, Arthur, do you want to take it away?
Yes, you should see my screen now. Thank you, Jason. Yeah, I'm going to dive a little bit deeper into how is this import working, what matches what in terms of subarrays to the PlantPredict hierarchy, and so on. One thing I want to point you to is that along with this webinar, we have just published a new page on our PlantPredict documentation, which is just part of our knowledge base about exactly comparison between PlantPredict and PVsyst predictions and results, and it goes over how you do your import, but also how do properties from the PVsyst side match the properties in the PlantPredict side in terms of plant topology, loss tree, electrical effect of shade models, simulation settings, and then a list of common pitfalls you can have because the tools are not necessarily exactly apples to apples. There is some concept that exist on one side and don't exist on the other. So in essence, porting a PVsyst project to PlantPredict, some of you may have done it manually before. It's a translation exercise, and it's very similar actually to a language translation. You may have realized my English is not my native language, and if you take the sentence, "My name is Arthur Ono," there are multiple ways to translate it in, for example, French, my native language. I can say "Mon nom est Arthur Ono," which is literal word for word, but it's awkward and no French person would ever say that. I can say "Je m'appelle Arthur Ono," which is the most correct way to translate it. which is literally I am called Arthur Ono, or I can say on m'appelle Arthur Ono, which means people call me Arthur Ono. And here I do something very particular, is that I'm adding context to my translation. When you take a PVsyst project and you add it into PlantPredict, you do have something similar. How do you make it the most correct possible without adding too much context? But you do need to add some context because PlantPredict has fields that are not present in the PVsyst original project. And so, for example, you take the concept of the subarray in PVsyst. What does it translate to in PlantPredict? Is it a DC field? Is it an inverter? Is it both of them? So this is the type of things that can happen. And for that case, the subarray translates to both. Another way to think about it is that if you work only in one software and have never worked into the other, this is how you maybe imagine how the two tools map to each other. On each side, you have nice plant hierarchy and 3D scene and prediction parameters and prediction assets, and they match nicely one to the other. You have the PAN file for modules on the PVsyst side. You have the PPM file on PlantPredict for the module file, and these would have exactly the same properties, and it would be easy to make this nice one-to-one relationship. You take one field, you just carry it over, and that's done, and everything goes directly. Well, in practice, it looks more something like this, where things do not map neatly. Some concepts are on one side and not on the other. Some of them mean things that are fairly similar, but actually it's slightly different. And then you have the worst case scenario, which is what I call the false friend, which is a property name that is very close between the two tools, but have a totally different meaning. And if you were just to take that field and copy and paste it from one side to the other, you would have your simulation totally wrong. So how does that work in practice? This is the full map. This is what our tool does behind the scene. I'm not going to go in detail into that. The goal is just to show the complexity. Here you have about 100 properties of a PVsyst project or PlantPredict project, and each field correspond. We made all these connections between all the fields. What is interesting here is that I've color coded it. It's a little bit rough, but basically green means direct import. You can take it from PVsyst, copy it to PlantPredict. It's going to work perfectly. Light green is minimal ambiguity. You may need to add some logic to it, but it's fairly simple. But then you have the blue ones. All the blue ones are things where you need a transformation or some interpretation, transforming a fraction into a percentage, taking multiple inputs and combining them and deriving the resulting property. And then in orange are the parts of PVsyst that are not used by PlantPredict. In red are another issue, all the parts that you need in PlantPredict to run it, but do not exist in PVsyst. For example, what is going to be your DC health, or the rotation speed for your irradiance optimization algorithm, things like this. And so for these ones, we need to populate them, and the way we do it is we take company defaults or we use our own defaults. I'm going to dive a little bit deeper into two of the elements, or three of the elements that happens when you do this import. The first one, because users are going to interact with it, is how do you do a plant hierarchy reconciliation? So PVsyst on the left here, the plant hierarchy is fairly simple. It's just a flat list of subarrays. So you have all your subarrays, and for each subarray, there is one inverter that can have a repeater. And then for each of these inverters, you have a module type, a number of modules per string, and a number of strings. And you have subarray 1 with 7 inverters with that modules, 30 modules per string, 200 strings. Then you have subarray 2 with inverter number 2, module number 2, and so on and so on. PlantPredict, on the other hand, has a much richer nested structure, which is we have blocks. In the blocks, there are one or multiple arrays. In the arrays, there are one or multiple inverters. And in the inverters, you have one or more DC fields, meaning that you can have two parts of the same inverter that has two DC fields with two different modules connected to it. And the logic here is that at the block level, you set the energization date if you commission your power plant little by little. At the array level, you have your transformer and medium voltage losses, and you can have a repeater. At the inverter level is fairly similar to the inverter concept in PVsyst, and the DC field is equivalent to the module part of the subarray in PVsyst, and the inverter can also have a repeater. But you can have multiple inverters on the same array, which would be the example if you have a skid with one transformer for two inverters. This is how the PlantPredict power plant topology handles it. So now, how do we match these together? And the way that the choice we have made is to do a one-to-one from block to DC field. So each subarray in PVsyst will give birth to one DC field, one inverter, one array, and one block. And the reason behind that is that the reasoning is that if you want to be able to have the most be able to adjust your parameters the easiest, then this is what gives you the most flexibility then to manage your power plant. If you want to stage how each inverter is turned on during commissioning or something like this. Another thing that I want to touch on, and that is important, is that the two tools have a different philosophy when it comes to loss analysis. Here on the left, I have PlantPredict, on the right, I have PVsyst, and the loss waterfall is exactly the same on both sides. You do get the same loss for each effect, but the way they're reported is different. So PlantPredict on the left groups losses, and within these groups, all of the losses have the same denominator. So going from POAI to DC power at STC, every effect goes with is the effect takes the loss divided by the POAI, and that way your losses are cumulative. You take 4% for I'm going to invent things here, but 4% for 3D transposition, 7% for shade, 8% for electrical effect of shade, 2% for soiling. You sum them, 4 plus 7 plus 8 plus 2, you get to 21%. PVsyst, on the other hand, is going to make these losses multiplicative, or they compound, meaning that each loss is based on the result of the effect of the previous loss. So even though these are the same number, PVsyst is going to report -4, -7.3, -9, and -2.5. You need to multiply these to fall back on 21. If you add them, you will get 21%. If you add them, we're going to fall on the wrong result. And this is important because that means that if you are comparing the two tools and like, wait, why is it that in PlantPredict the electrical effect of shade is -8% and in PVsyst it's -9%? There is 1% off between the two tools. No, there's not. In this case, it's exactly the same number. What is happening is that the way they're reporting it and the denominator in the loss fraction is not the same. And to illustrate that, I'm going to use our NCP server. So I'm going to swap to my cloud interface. So this is, I'm going to go into light mode so that it's easier for users. Here we go. And so it has not swapped yet. Here we go. You should see now my browser. And in my browser here, I am showing my cloud interface. And what I'm going to do here is it's connected to the PlantPredict MCP server, so it's able to pull information from PlantPredict, and it's also able to interact with PlantPredict and ask it to do things. I'm starting with a very simple prompt. I'm starting slowly. I've run all these already for the sake of time. It takes some time for some of these prompts to run. It can take like 1-2 minutes. So we don't really have the time here. So I've run everything, and we're just going to go through what has happened. And so I'm just saying I have imported a PVsyst project in PlantPredict, project ID 314774. Using the PlantPredict MCP server, I want to confirm that the inputs closely match across both models. Let's focus on the 2D prediction for now. I want to load it. I will upload the PVsyst report once that is done. And so what it does is it's able to find the project, find the 2D prediction within the two of them, find, oh yeah, based on the name, this is the 2D prediction, and this is the summary of the power plant. These are the model choices. These are the losses and the rates that are being used, and it finds two things that are odd. One of them is that the DC wiring loss is set at 1.25% on one of the DC fields, whereas it's 1.5% on all of the others. And then it finds also that the light-induced degradation for the power plant is set at 2%, where the module definition gets it at 1.5%. These are actually not real issues, but because it doesn't have the information from the PVsyst side, so it's like, hey, there is a bit of things that are a little bit confusing here. Now I'm uploading the PVsyst report, and I'm not uploading the zip file or anything. I'm just taking the report here. I'm saying PVsyst report attached. I only want to compare the inputs for now, no comparison between the results yet. I'm going to give it a hand. Here is a guide to comparing PVsyst and PlantPredict predictions, and I want a short answer because otherwise it can go pretty long. And what I'm sharing is this this page I was talking about before, the comparison between PlantPredict and PVsyst that we have published recently. So it goes on, and it compares all of the different inputs. It finds that pretty much everything matches, and it finds a few things that are different. The site elevation is slightly different because the reference is not exactly the same. The medium voltage transformer rating is slightly different also, and that is going to affect probably a tiny bit the losses at the medium voltage transformer level, because these losses are based on a percentage, and it's a percentage of the nominal rated power. So that's going to drive a little bit of a difference. Very, very minimal changes on the IM side. And then the auxiliary loads. So PVsyst does not have a lot of definition for auxiliary loads. PlantPredict is much more detailed, and so when we imported, we used the defaults that are set for the Terra-based company. So that's why there is a difference here. So it says basically there are only two issues that can really happen. The last issue on degradation is actually a hallucination on its part. So you need to have some critical thinking when you look into this. And now we keep going. And that's the part that is interesting. And I'm going to tell it, PlantPredict and PVsyst loss waterfalls are computed differently. It's additive for PlantPredict. It's multiplicative / compounding for PVsyst. I want to transform the PlantPredict loss waterfall into a multiplicative loss waterfall comparable to PVsyst, and I want to compare losses between the two tools. And here is a guide from PlantPredict on how all these losses are calculated. And this is another part of our documentation that is on the P50 loss tree that explains how it works and what is the formula to calculate every one of these. And this is going to tremendously help Claude to understand what's going on, and that it's figuring out what's the conversion method, and it goes into it. It's going to reproduce the whole loss chain for the whole PlantPredict power prediction and make it something that is comparable with PVsyst. So you start from exactly the same GHI. You see that after POA, you get very similar results, very, very close effective frontier radiance, but a little bit of a difference on the rear side. And as a result, you have an effective total that has a bit of difference. So I'm not going to go into every detail here, But at the bottom, it's going to be like, yeah, you have 0.46 difference between these two power plants. And pretty much all of this is due to your rear side irradiance. PVsyst and PlantPredict have different models for the rear side irradiance, and that drives about 0.5% of difference between the final power assessment. Near shading is also a little bit less aggressive on PlantPredict because of the backtracking algorithm being slightly different and the GCR being slightly different. And then you have also a little bit of inverter efficiency difference, AC collection loss difference, and this auxiliary loss. And so if you sum all these together, you land on this 0.46%, but it really starts at the rear side irradiance difference due to these different models. So if I go back to my presentation, this was one case where things need to be aligned, and they're pretty hard to do by hand, but using our MCP server, it's much easier to do and just takes a couple of minutes. Another example of things that as a user you may run into comparing these two tools is that in some cases you can have the exact same physical model, the exact same energy inputs and outputs, but a different bookkeeping. So the losses are going to be different, but the in and outs are going to be the same. And it's just because these are counted differently. And one case where this happens is going from your curve without series resistance, your power without series resistance, and adding DC side wiring losses, series resistance losses, and clipping losses. And because TeraBase and PVsyst do not do these in the same order. So on the left here, in both cases, what I've plotted is the same power voltage curves. In blue without the series resistance, in orange with the series resistance. And we'll start with PVsyst on the right. The way PVsyst does it, it takes these two power curves, it determines the difference between the two maximum power points, and this difference between the two maximum power points is the ohmic losses, the DC wiring resistance losses. And then from that maximum power point after resistive losses to the clipping power, that is your clipping loss. On the other hand, TeraBase is applying that a little bit differently. The way it does is that it figures out what is going to be the clipping power operating point, and from there it's going to calculate what is the clipping current. This clipping current is the base on which you calculate your wiring losses. You take your clipping current, you square it, you multiply it by the series resistance, and that will give you your clipping loss, sorry, your series resistance loss, and the difference between that and your power without series resistance is then your clipping loss. What that means is that series resistance tend to be lower in PlantPredict, and clipping loss tend to be higher in PlantPredict. And on the other hand, in PVsyst, you have lower clipping but higher series resistance losses. And but at the end of the day, the power in and the power out are the same. And we can go back to our MCP server and ask it about that exactly. Hey, I know that these have both these losses. How do they interact? What is the net effect on my prediction? And so here I'm asking it, how do DC wiring and clipping interact on both tools? What is the net effect? It's explaining the mechanism, which is exactly what I was talking about. PVsyst computes the resistive losses on the full MPP current. PlantPredict computes the resistive losses on the reduced clip current. And then it's figuring out that, yes, the sum of these two, there is a difference. DC wiring there's a difference of 0.15% on the DC wiring losses and a difference of 0.5% in the clipping losses, but that matches what you get as an input. So the resulting difference of about 0.35% is due to what you feed to the model and not to the way the model works itself. And it's the same physics happening in the exact same models. And then we can go again and do the exact same thing for the second prediction in there. I'm telling it I want to do the same analysis with the 3D model now. The PVsyst report is attached. I'm not going to go in details here, but what it's finding is that what drives now the minus 0.51% difference is pretty much mostly the electrical shading effect and then the near shading effect. Together, they explain how the prediction results switch. What I want you to take away from here mostly is that the tools can do bookkeeping a little bit differently. And if your predictions match within 0.5% from one another, and every single loss is within 1% of one another, you have two models that are very, very well aligned already. It's only when you start to have higher differences that you should try to figure out what is going on with my inputs and with the models themselves. And with that, I'm going to hand it back the presentation to my colleague Jason.
All right. Hey, thank you. Thanks, Arthur. So with that, we've got our second poll question related to kind of the use of PlantPredict's MCP server. We're curious what most people are using out there as their AI model of choice. ChatGPT, Claude, Cursor, Copilot, or other. And give that a minute to come in. All right, so we've got most people are using Claude, with about a third of you using Copilot, and then ChatGPT being in third place with 18%, other 9%, and nobody using Cursor, which kind of makes sense because that's more of a development environment. Okay. So with that, we've got some closing notes. Arthur, if you want to move forward. So recent updates, obviously new import tools. So we covered PVsyst today. I briefly mentioned PV Farm, but that's also, a huge milestone to be able to bring project information directly from PV Farm into PlantPredict and retain all of the design detail from PV Farm and bring that model into PlantPredict. And it's really encouraging to hear, from the first poll question, how many of you responded that integration with design modeling software was a top priority. SunSolve is also, we've continued to have a relationship with SunSolve and continue to evolve that, the ability to integrate with SunSolve. We've introduced flexible pricing for our Pro subscription. So on the commercial side, you can now sign up for a Pro subscription as a single user, which was not previously the case. Previously, you had a minimum of 3 seats. So as Arthur demonstrated, we've released the ability to use MCP server for Pro and enterprise users. Right now we have an MCP connector for Claude and the ChatGPT, but not for the others. We're working on the others as well. We've published new bankability studies from 2 IE firms, ICF and Solfi. Both of them have compared PlantPredict version 12 against PVsyst version 8. I think Solfi actually compared against version 8.1 and ICF against version 8.0. Interestingly, I saw a question in the chat. I'm going to go ahead and jump on it. Given this, there was a question about sub-hourly and the ability to, can we bring in sub-hourly data from PVsyst, and does PlantPredict used the adapted Perez transposition model for sub-hourly modeling. So yes, we can bring in sub-hourly data. No, we do not currently use that adapted Perez model that was introduced in version 8.1 of PVsyst, but Solfi did do a comparison of PVsyst versus PlantPredict, given that sub-hourly, that new introduction of the sub-hourly model in PVsyst side. So I would check that out. Okay, next. We've rebuilt our knowledge base. You can now access our knowledge base via an in-app chat agent. So within PlantPredict, you don't have to go to the knowledge base and look something up or search for it. You know, while you're in PlantPredict, you can actually type questions and get responses that are access to our chat agent. Upcoming features, so PVC2 compatibility is coming soon. We've actually just released the ability to read in PVC2 just the geometry, so just the shade scene portion of PVC2, but we are working on being able to pull in all of the electrical mechanical hierarchies and system information as well with the PVC2 data, so that's coming. And then upcoming webinar, we're going to go much deeper into AI and PlantPredict's ability to interact with AI. You know, PlantPredict with its API and MCP server, which is really just providing context between the AI agent, your AI agent, and PlantPredict's API. We're going to be going much deeper into that in an upcoming webinar. And so with that, I think we'll take some questions. So let me, we've got, I was looking through the questions earlier. We've got some really great questions here. And clearly people are really interested in looking into the details. So first question, does PlantPredict support the latest PVsyst version 8.1.5? Yes, actually the demo that I gave today was using 8.1.5. We've tested we've primarily tested the import process with version 8. We have done quite a bit of testing in version 7 as well. We have not tested import before version 7, so be aware of that. Also, be aware that, you know, these file formats are not publicly sort of published in terms of what the contents are and how they're structured. So this is really PlantPredict working to try to make our users' lives easier and sort of going beyond what is kind of out there in terms of published knowledge from PVsyst. So, okay, next question. Has there been any independent validation studies conducted that compare PVsyst results to PlantPredict? Yes, so there's quite a few. So we have a validations page, and we've got quite a few sort of historical publications. The most recent were from ICF and Solfi, which compared, as I said, version 12 to version 8. We've also got a study in the works from Leidos that we'll be publishing soon. There's a question, why change the loss calculation, PlantPredict using common denominator for loss categories versus using PVsyst method? Is there an advantage using PlantPredict's method? So I'm gonna let Arthur respond to this, but the first thing that I want to say, just to be clear from the outset, is that from a megawatt hour calculation perspective, both models are approaching these sort of physical models in very similar ways. It's really the reporting of the losses on a percent basis where the sort of, you know, the PVsyst waterfall that we're all familiar with and the PlantPredict loss tree, on a percent basis, we're using a different sort of a different way of calculating that percent. And so a lot of times people try to compare these on a percent basis, and it looks like things are further off than they actually are. Aligning them, you know, doing the math to really compare them on a megawatt hour or kilowatt hour loss basis is really the right way to compare them apples to apples. Arthur, do you want to add anything to that? I think you covered that, but it was maybe a lot.
Yeah. Yeah, it's really a question of difference of philosophy and what you're trying to achieve with these. There is no way that is better than the other. The advantage of the PVsyst approach is that you don't have to know anything about this organization to be able to compare all your losses. But the advantage of the PlantPredict approach is that you can actually compare um, in absolute value two different losses. So in PlantPredict, if I'm losing 20% and 20% again, I know that these two losses, if they are in the same group, they are the same number of megawatts. Whereas in PVsyst, if you lose 20% and 20% again, when actually in absolute value, one is 20% higher than the other, one is going to be 20% absolute and the other is going to be 16% absolute. So it's just a question of how you want to compare these and how do you want to compare these buckets and how much there is in one versus how much there is into the other. One thing I would like to work on is actually a way we can toggle our loss tree to go from one mode to the other, so that it makes it much easier for users if they're like, oh yeah, I want the multiplicative way all the way down. Well, I toggle this and I know how my losses are multiplicative. I prefer to have the additive way. I toggle back to additive, and that's something that has been in the back of my head for a while. Hopefully, maybe it's going to happen before the end of the year. Yeah.
Great, thank you. Next question, interesting question. Do you think there would ever be a way to link module inverter libraries between PlantPredict and PVsyst so we can just pull from one master source to help better protect project data integrity and reduce transfer errors? Or that really cannot happen because these are still two distinct softwares? Yeah, that's a really interesting question. I know that people, and there has been situations in the past where module data specifically there's been, people have tried to create sort of a central database. One of the challenges um, is really the, who takes responsibility of the data itself. Really, it should be the manufacturer taking responsibility of the accuracy of the module data. In terms of PVsyst and PlantPredict, I think both companies have file exchange formats. So, Terbase, the PAN file has essentially become kind of the industry standard way of representing module data. And, I think I don't see us, collaborating with PVsyst to create some sort of centralized database would be my instinct, but really, like, I could see the value in why that's important. Arthur, do you want to add something to that?
Yeah, so one thing is that one of the issues is that if you export into your zip file, zip format, a project with a module which is in the PVsyst database, it's not going to be exported as a PAN file into the zip because PVsyst is able to retrieve it by itself, which is an issue in itself. We are working on to how we could, circumvent that and be able to pull that data. In the meantime, one thing you can do is you can open this module in PVsyst. You can change one character of the name or the description, something that is not a numerical value. Call it, I don't know, module number 1 dash PlantPredict export. And that way you can save it as a PAN file. And now it becomes something that is going to be exported with the zip file. So if you encounter this issue, that's the workaround we have for now.
Great. That we're right at the top of the hour, so we've got a couple more questions that we weren't able to get to, but I'll cut it off there. And I just want to say thanks to all who have joined. Hopefully this was informative. And for any questions we didn't get to, we will definitely send a response via email in the coming days. So thank you very much.